square roots, yes, square roots is part of it. So when we talk about a set, okay, says what? A set consists of what? Irrational numbers, okay? Says what? Irrational numbers. So like she said, when you have square roots, right, square roots are always what? Irrational numbers, and they always resolve, the results are always what? You do not get what? A whole number. So let's say, for example, if you have a square root of what? 2. If you have the square root of 2, the result is not going to be what? A whole number. It's going to be what? A decimal. And that is what? An irrational number. But if you have square root of 4, for example, the square root of 4 is going to give you what? A whole number, which is what? A rational number. So square root of 4 here is not what? A set. Because it's going to give you a whole number. So on the sense, we only deal with what? Irrational numbers. Okay? And we say that the square root of all prime numbers, are sets. Because then they are going to give you what? A whole number. Alright? The square root of all prime numbers are sets. So whenever you are working out a set and you get what? A prime number inside the square root, it means that is what? The simplest form of that set. If you have the square root of a prime number, it means that is the simplest form of the set. You know that with sets, we always deal with what? Simplifying it. Okay? So if I give you something like square root of 8, square root of 8. Square root of 8 is what? An irrational number. Okay? We are not going to get a whole number. But we can simplify the square root of 8, okay, for it to give something what? Much smaller. So with square root of 8, we know that 8 is can be written or can be broken down to what? Square root of 2 times 4. Okay? 2 times 4 will still give us what? 8. Isn't it? So with this one here, and from the beginning I give some of the rules of what sets. That sets can be written separately. That's if they are multiplying. So some of the rules are what? If we have square root of a times b, okay, can be written as what? A times b. Okay? If we have a square root of this sort, we can write them separately. So when we come here, we can apply this rule. Okay, we can apply this rule. So this will give us what? Square root of 4 times square root of what? 2. And we know that the square root of 4 will give us what? A whole number. Alright, so the square root of 4 will give us a whole number, gives us 2. But the square root of 2 and the 2 being prime number means what? It is the simplest form of that set. So we leave it just like that. So we are going to have what? Times square root of 2. And we know that this will give us what? 2 root 2. Okay? So whenever I ask a question, whether I take exams or in class, then you get what? The square root of a number, okay, being even number or whatever it is. If it is not a prime number, then it means that it can be reduced into a much simpler form. Okay? So you find what? The factors of the number. Right? Then you multiply it. Multiplying, after you multiply it like this, okay, it means you can separate them into 2 different parts. Then what do? You reduce it to the simplest form. In sets, so let's say for example, you were working out and you have what? Square root of 8. If you leave your answer in this form, you are correct, but you are not going to get full marks because you are not done. This is not the simplest form of what I said. So always try and leave your answers in the simplest form for us. Okay? So let's solve this example here. We have square root of 24 plus, let's say, root 6. Okay? Square root of 24 root 6. Right now, if you look at square root of 6 here, we know that 6 is what? An even number. And it is not what? An odd number. But it doesn't have any factor that can be the perfect square. Right? It doesn't have any factor that's a perfect square. So the 6 can be broken down into what? The factors of 6 for 1, 2, 3, and the 6 itself. So here, if we are to write them as what? 2 times 3. The 2 here, we can reduce it. The 6, the 3 also can be reduced. So it means that the 6 here is the simplest form of this set. Alright? It means the 6 here is the simplest form of this set. So it means we leave it just like it is. Okay? We leave it just like it. But when we come here to 24, square root of 24, we can see that we can find out a perfect square in it. And what will be the perfect square? Which is what? The multiple of 24. We know that we have what? 4. And 4 times what we do is 24 times 6. Okay? So the 4 times 6 will give us what? 24. So here we are going to have what? That's 6. So, like using this method, okay, we can write what? Square root of 4 gives us what? So 2 root 6 plus root 6. And we know that we can only add or subtract sets when the numbers in the square root are the same. You can only add or subtract a set when the numbers in the square root are the same. If they are not the same, you can't add or subtract them. You can only add or subtract them. But with multiplication, it doesn't work that way. Okay? Right now we are talking about what? Addition or subtraction. With the addition or subtraction of sets, we can only add or subtract them when the numbers in the square root are the same. So here, because we have what? Square root of 6 and square root of 6, it means we can add them. So we just add the numbers outside the square root. So 2 root 6 plus root 6 equals what? 3 root 6. Okay? So that will bring us what? So root A plus root A gives us what? 2 root A. Okay? So that's if the sets or the number in the square root are the same, it means we can what? Add them together. Let's come to the third one. If we have A root B, okay, times root C, okay, A root B multiplied by what? Root C. Here, what do we do? Because it's multiplication, okay, multiplication of sets, it doesn't matter the number in the square root. We multiply the numbers inside the square root, okay? So when we come here, we have A square root of B times square root of C. Root B and root C are not the same, but because this is what multiplication, it means we can add, we can multiply them. But when it comes to addition or subtraction, you can't. But with what multiplication and division, you can do that. Okay, so when we come here, this is going to give us what? A root B, okay, times C. So let me write them together. Times C, okay, which is going to give us A root what? B, C. Is that clear? With multiplication, this is how it works. Multiplication of sets and the addition of sets is very different. You can only add or subtract the sets when the numbers in the square root are the same, but with the division and multiplication, you can add you can multiply or divide, whichever question that is being given. Okay. And so we have what? That reduction to its basic form. So that one I will explain